Okay, so here we're talking about distance time graphs. I'm just going to draw out a distance time graph so you can see what I'm on about. Okay, so we've got here our distance time graph and our plot. So there's a few things to note when looking at these graphs, and the first one is that the gradient equals the speed. So anywhere on this graph, the gradient of a line will equal the speed at which whatever is travelling. So if this plotted the distance of a car against time, then this line here would give the gradient of that would give the speed of the car. And so consequently, if the line is steeper, if the gradient is therefore steeper, then whatever it is travelling faster. So I'll write that here. Steeper equals faster. Okay, so the flat areas of the graph mean that whatever is travelling has come to a stop. So at those flat areas, they're not going any further distance, so whatever it is that has been moving has stopped. And if you have a negative gradient, it means that whatever has been travelling is coming back. Here we have a negative gradient, and whatever it is that has been travelling a distance is now returning. Okay, so I'm going to go through this graph now, and I've come up with a little example of what it could show. So I'm saying someone has decided to go out for an afternoon walk. They've started at the car park and they've set off walking, and at 1 p.m. they decide it's time for a nice picnic lunch. So between 1 and 2 they stop walking, so it's flat, they stop walking and they have their lunch. And then they decide to carry on a bit further because they know there's a beach around the corner. And so they keep walking further away at a slightly slower pace. Then they get to the beach. So from 4 till 5 they decide to have a bit of a sunbathe. Not very sunny between 4 and 5, but there we go. They sit on the beach for an hour. Then they decide to walk home, and they walk much quicker because they've got hungry again. They're running back for dinner, I suppose. So that's just an example of what this could show. I'm now going to go through some questions. I've printed them off because it's useful to have an actual scale diagram. So the question I've got here says, Emma travelled to her grandmother's house and back. The distance time graph shows information about her journey. So if we just go through this, you can see that the line starts from here. So this is when she starts her journey. So she travels to her grandmother's house. Flat line means she's stopped, so we can assume here that she's reached her grandma's house. And then she comes back. For her back journey, she changes her speed because the gradient changes. Okay, so now let's have a look at the questions. A, what time did Emma begin her journey? Well, you can see from the graph that she begins her journey here at 7:30 a.m. How far was Emma from her home at 8 a.m? So to answer this question, we go to 8 a.m. and we run our finger or our pen up to see where the line crosses it. And then we just read off the distance to see how far she's gone. So at 8 a.m, Emma has gone 20 miles. Okay. How long did Emma stay at her grandmother's house? Well, we know she stayed there when the line's flat because that's when she's not travelling any further from anything. She's stopped. So we just have to read off the time. So the flat line starts here at 8:30 and it ends here at 10 a.m. So we just need to know how long she's been there for. So she's been there from 8:30 a.m. to 10 a.m. So she's been there for 1.5 hours. What time did Emma leave her grandmother's house? Well, we just had to work that out. We just saw that she left at 10 a.m. How far was Emma from home at 11:45. So on our time scale we go to 11:45, which is here, and we read off the distance. So here she is 7.5 miles away from home. Because you can see here she's returning to home. She started at home and she's returning to home. So here, although she's travelled all this distance, she is in fact only 7.5 miles away from her home. And how far did Emma travel in total? Well, to get to her grandmother's house, we can see that she travelled 40 miles. And to get back, she also travelled 40 miles. So in total, Emma travelled 80 miles. So even though she did it over slightly longer time when she was travelling back, because her speeds were different, she still travelled in total 40 miles on her return journey. Okay, so I hope that gives you a quick introduction of distant time graphs